Currents and circuits. We are familiar with the phrases air currents and water currents. They both refer to the net flow of fluids from one point to another. An electrical current can be visualized as a flow of charges inside a conductor. A useful analogy is to imagine charges flowing in a conductor the same way water flows in a pipe. We can conceptualize electrical current as the amount of charge flowing across a given cross-section of a conductor at any given instant. Mathematically, we can define current as I equal to Q divided by T, where I is the symbol for current, Q is the symbol for charge, and small t is time. So we can say that electrical current is charge flowing per unit time. Today we know that the current in a metallic conductor is composed of trillions upon trillions of free electrons. But hundreds of years ago, when the phenomenon of electrical current was first discovered, we were unaware of the existence of electrons and conceptualized current as the flow of positive charges. So we still have a convention of current caused due to the flow of positive charges, which flows from the positive terminal to the negative terminal. It is important to remember that the direction of electron current is the opposite to the direction of conventional current. The standard unit of current is ampere, denoted by the symbol capital A. André-Marie Ampere was a French scientist who first conceptualized our understanding of current. A conductor is said to support 1 ampere of current if 1 coulomb of charge flows across any given cross-section of the conductor every second. 1 coulomb of electrons is approximately equal to 6 times 10 to the power 18 electrons. In daily life, it is much more convenient to use units like the milliampere, which is 1,000th of an ampere, or the microampere, which is 1 millionth of an ampere. And these are used more often. What is a circuit? A circuit is a closed, continuous path that is composed of conductors or conductive electrical devices that provide a route on which charges can circulate again and again. We can measure the current in a circuit with the use of an ammeter. An ammeter is always connected in series with the circuit whose current is to be measured. Please note that unless otherwise specified, when we use the term current, we are referring to conventional current which flows from the positive terminal to the negative terminal. Looking at the diagram, we can see that the ammeter is connected in such a way that its polarity matches the polarity of the circuit. Polarity simply means how the positive and negative terminals of the electrical energy source are placed with respect to each other. Let's try a simple numerical problem to understand electrical current a little better. Let us say a circuit supports a current of 10 amperes. If it is operated for 10 minutes, how much charge has flown through the circuit? From what we have just discussed, we know that I is equal to Q divided by T. If we were to transpose T to the other side, on the left, we can see that I multiplied by T gives us Q. Since T is equal to 10 minutes, which in turn is equal to 600 seconds, Q would be 10 times 600 or 6,000 coulombs. Remember, it is important to make sure that all the units in the problem are converted to standard international units before you begin any calculations. This will save you a lot of trouble later.